Hey there! Welcome. Today, we're going to tackle a classic puzzle. How do you perfectly measure the distance around a circle? It seems a little tricky, but trust me, by the end of this, you'll know the secret. Let's dive in. So, picture this. You've got a bicycle tire, maybe a dinner plate, and all you have is a straight ruler. It's just not going to work, right? That curve makes getting a perfect measurement feel basically impossible. So, how do we crack this problem? Well, this whole round edge problem actually has a super elegant solution. And it all starts with just giving that distance a proper name. And that official name is the circumference. You can kind of think of it like the perimeter, but just for circles. We're not talking about the space inside it, just the total length of that path all the way around the outside. Okay, so how in the world do we calculate this circumference without some kind of flexible wraparound ruler? Well, it turns out that every single circle in the universe, big or small, doesn't matter, they all share a secret number that unlocks this entire calculation. There's this one special number that's like the magic key to the whole thing. It connects a circle's width to its circumference with perfect mathematical precision. Any guesses what it is? You got it, it's 3.14. I'm almost certain you've seen this number floating around before. This is the secret key we were just talking about. And trust me, it's about to be your new best friend for solving this puzzle. So we call this number pi, and you'll see it written with that Greek letter pi. Now, the really cool thing here is that pi is a universal constant. That means it is the exact same fixed ratio for every single circle that has ever existed or will ever exist. Seriously, if you take any circle's circumference and divide it by its diameter, you always get pi. Now, for what we're doing today, we'll just stick with the common approximation, 3.14. All right, so we've got our secret weapon, pi. But, to actually use it, we still need one more piece of info about our circle. Luckily, there are two really simple measurements we can use to get the ball rolling. First up, you've got the diameter. The easiest way to think about this, it's the line that cuts a pizza into two perfect halves. It's the full distance straight across the circle, and it has to go right through the center point. And your second option is the radius. Now, if the diameter is the whole journey across the circle, the radius is just half that trip, from the very center out to the edge. Which means, the radius is always going to be exactly half the length of the diameter. Okay, so let's make sure that sinks in. Diameter is the full width. Radius is half the width. If you know one, you automatically know the other. So if a diameter is 10, what's the radius? Yep, 5. If a radius is 3, the diameter's got to be 6. It's that simple. And this relationship is absolutely key. So, how do we put all this together? Well, we have two super simple formulas. If you know the diameter, the circumference is just pi times the diameter. Easy. If you only know the radius, the circumference is 2 times pi times the radius. But wait a sec. Look at that second formula. What's 2 times the radius? It's just the diameter. So really, they're the exact same formula, just written in two different ways depending on what you've got. Okay, enough talk. Let's make this real. We're going to take a circle, an actually calculated circumference, using both methods just to prove that they both work perfectly. All right, let's say we've got a circle with a diameter of 10 centimeters. We grab our formula, c equals pi times d. Then we just plug in the numbers. That's 3.14 multiplied by 10. And boom, our answer is 31.4 centimeters. Simple, direct, done. Okay, but what if we only knew the radius of that same circle? Well, if the diameter is 10 centimeters, then the radius has to be 5, right? So we use our other formula. C equals 2 times pi times r. Let's plug in those values. 2 times 3.14 times 5. And would you look at that? We get the exact same answer, 31.4 centimeters. And this, right here, is the big takeaway. It doesn't matter one bit if you start with the diameter or the radius. As long as you pick the right formula for what you have, the math is going to lead you to the exact same correct circumference every single time. It's just beautifully consistent. So there you go. That round edge problem we started with, turns out it's not really a problem at all. With a little bit of logic and one very, very special number, any circle you can think of is totally measurable. All right, let's do a super quick recap of the most important stuff. First, circumference. That's just the fancy word for the distance around a circle. Second,
Our secret key is always pi, which we can round to 3.14. And finally, you just got to pick the right tool for the job. Got the diameter? Multiply it by pi. Got the radius? Multiply it by 2 times pi.
So you've totally mastered the outside edge. You can now calculate that path all the way around any circle. But that kind of leads to another interesting question, doesn't it? What about all that space inside the line? Well, that sounds like a puzzle for another time.